Hello, everyone, and welcome to our first workshop in the Cybersecurity Cybertruck workshop series in hosted by the Q Project. My name is Arman Kapoor, and today our topic we are covering is Pi-hole. Uh, so this is in this infographic, you can see how the entire process of when you enter a URL into the address bar and how it gets rendered onto your actual laptop from the server. And in the very beginning, there's something called a DNS. This stands for a domain name system, and this part right here is what we're going to be covering today, or what's applicable for today. So, what is DNS? DNS stands for Domain Name System. It basically turns human readable names into IP addresses. For example, google.com is one. Um, and when the computer or it, computers don't know what google.com means, they only know IP addresses. And so what DNS does is turns in the google.com into an IP address. And IP addresses are of the Google server, which the content is derived from. So when I visit google.com, I go to the IP address of the server and it gets all the content, whatever I ask for. For example, this is Google's IP address. Um, there are basically two parts to this type of system. So when there's a client side where the user enters google.com into address bar and it issues a DNS query request. That's how it gets resolved into an IP address, and then it gets sent to the um, server, and then you'll be able to get the information or the content from google.com's from Google server. Um, so how does it work? So I'm going to be using this graphic right here to explain how it works. Basically, naming system is hierarchical, and caching is used at every stage. So, for example, the client first goes from here. It goes to the top level domain, which is .edu, goes up there, and this name server says, okay, all the edus are stored, all the Princeton ones are stored here and the edus, and then it keeps going down from edu to Princeton to CS to Penguins all the way down here, and then it finally gets the IP address, comes back here and goes over here to the originator, basically the client. That's if there's no caching available at each of these. So, for example, if there's caching, then this one um, maybe the DNS is already stored in the client, so there would be no need for a DNS query request. Otherwise, it would go here, sometimes get caching here, and then go straight to penguins.cs.princeton.edu in case if it knows the name server. Then it goes here, it gets the IP address, or it goes here, or here, or here. It goes the other way around for to get the ones that most recently cached. So, what are some security issues of DNS? So, the wrong binding, which is from the name to the IP address, could lead to a different IP address resolution. And this means that the attacker could spoof the DNS reply, and this is known as DNS spoofing. This is a bit harder with DNS security extensions. For example, it's known as DNSSEC. You may have heard about that before. And it basically replies the DNS reply. And that's basically it. So it does not validate where the DNS reply was sent. It just validates the reply. That's it. So I'm going to be talking about what is a DNS sinkhole. It's a sink. Other names include sinkhole server, internet sinkhole, or black hole DNS. Basically, this can generate fake replies, and it allows attackers to redirect users to malicious sites by giving them the wrong binding to the DNS. It leverages caching and the hierarchical caching system of DNS. That would mean more requests would be better performance, and the higher the level of DNS um, in the domain system would offer more uh, requests being denied or falsely replied. For example, in the root name server, let's say the DNS sinkhole is here, all of the edu domains would be could be like falsely replied to a different server. In The DNS sinkhole can be placed at the network level or at the host level. This is at the client level. There's a file on your system called etc-hosts in the etc folder, and you can actually type in the DNS manually. There's also some constructive use cases for a DNS sinkhole. For example, there is the WannaCry and Avalanche um, viruses that were be able to beat with a DNS sinkhole, and you can also target botnets. What it does is basically blocks DNS requests that supply the commands to the botnets, and it so botnets are rendered useless. Uh, and we've been talking about ad blocking with the Pi-hole. That's what the Pi-hole is used for nowadays. So we're going to be using it as a network level blocking. So let's say there's devices at your home in your home. There's multiple devices that speak to a router and the internet. So if if I want to get something from the internet, I go to the router, then go to the internet, and the internet goes back, or a reply gets sent back, and then goes back to my router. But with the Pi-hole, a DNS request from the device to the internet would first go to router, then to Pi-hole, then to the router, and to the internet. This is, of course, only one um, way of doing a network level wide blocking. What else you can do is actually, if you can just have a Pi-hole on just one device by setting up a Docker system, or um, just yeah, I think you use a Docker image for that. So I'm just gonna quickly go over the benefits and features. You can also include it as a DHCP server. That's where it gives the IP addresses out to everyone. You can import blacklist, import whitelist. It's easy install with less hardware requirements. It's scalable with the right hardware. It's good enough on a Raspberry Pi, which is a small computer. It must be connected to using Ethernet for the fastest response. Um, it uses Docker, and for the list or for the domains that are being blocked, there's something called regex, which you can use, which I'll um, briefly show you where you can do that. And caching is at the IPv4 and IPv6 level as well, and it's open source. So this is my works cited, and now I'm going to do a quick demo. I think I have it open right here. Right here. So this is the page you go to. Um, this is my local IP address right here. Not this is my Pi-hole's IP address on Raspberry Pi. I'm at the admin. You can see some of the DNS queries here. I haven't connected to my network yet, but I just wanted to show you what's going on. So there's 60,414 domains on block list. These are mostly ads. Um, you can log in with the password. Let me type this in. 8ZV. Okay. So here you can, it's basically a dashboard of different um, items. For example, there's um, PTR for what kind of query it is. There's um, queries such as one to one, one one. These are um, domains that are specific to the domain list that's being updated. For example, um, where this Pi-hole gets its DNS request from, like the legitimate ones, is from Cloudflare. There's different ones, different public DNSs out there. There's Cloudflare, there's Google. Google's a big one. Um, I forgot where you could check that. This you can also add a local DNS record, domain and IP address. Um, Group management. If you look at the ad list, this is where it gets all the lists of the domains that need to be blocked. For example, let's go to this first one right here. That's right here. What it does, it's similar to the host configuration file, which I just mentioned in your host computer. So basically list the domains names right here of the ones that need to be blocked. For example, Google, there's Google Ads here, ad service right here, and it sets the IP address to 0.0.0.0. Does anyone know what that means? What does that do? Effectively do. So when a in a regular notation in a regular um, world without the ad blocker, what this domain does, for example, if you're going on a website and it calls this for serving you Google Ads, it'll make a DNS request to know where the IP address is. It goes there, gets all the ads there. But what this does is saying ad service is actually located on your zero point 0.0 on your local on your this IP address. This IP address basically says that okay, basically it's on your laptop and um, it, it has an invalid IP address, meaning that when you query it or when you when you ask for the content, it just replies with null or it replies with blocked or 404 not found. So that means, let me type in 0.0.0. This site can be refused to connect. So basically, it doesn't even connect, and it basically tells the tells the computer that this you can't you can query it, you can send get requests to the server, but the server is local, but the server is not even connecting to you, so it'll just call it as a blocked um, endpoint. Does that make sense? Yeah, it's basically a null address. So thank you for coming. There's also different ways you can do lots of stuff, different things you can do with a Pi-hole. It's really easy to set up. You can add lists. Um, you can make groups. You can make clients. There's also whitelist and blacklist. So blacklist is basically all the domains you want to um, block. Whitelist all the domains you want to keep. Um, there's a You can add the actual domain letter by letter, character by character, or you can add a reject filter. Um, Reject stands for a regular expression. So, for example, um, this is probably wrong, but what if I want to do anything that has ads in it? I want to delete, or I want to put this on a blacklist. So even if so, stuff like Google ads would get blocked, but even stuff like ads, some main, or if that's a legit website and that's something you actually want to go to for like for school or something, this will get blocked because it has the term ads into it. So there's different expressions you can make for ads. For example, if it has ads and a dot somewhere, either in the beginning or in the back, then you can delete it or you can put it in a blacklist. The same way, same thing for whitelist. You can keep there. Some other cool statistics are on the top left. There's active status. There's what kind of load. For example, if there's lots of devices on your network, you want to try to look at the load to make sure it's not too much. You can see a temperature of the Raspberry Pi in case if it gets too hot, and then the memory usage. The memory usage is important because of what functionality of the Pi hole. Anyone?
I'd say, isn't it because it's storing all these DNSs to blacklist or whitelist?
Yeah, that and what other feature? It starts with a C.
Oh, the cache?
Yeah, caching. I was kind of hoping someone else, but good. That's good. Caching. Because it does not, should not cache like every single DNS. Because if it does, then you're basically um, losing that much memory. Plus, if the server IP changes, then you might want to go out again, of course. So that was basically my um, workshop for today. Thank you for coming, and I hope you enjoyed. Does anyone have any questions? You have a question? Can you still block ads, but somehow still accept a similar Google search with ads? I'm not understanding. He's block. So basically, when you go to a site which has ads, what it does is it downloads the actual site content, and then it also in that site content it has JavaScript sources that go to that request ads that are separate from the content, and um, it opens that up. But if it's blocked, then it does not open the ads on the actual site. Um, if I think so, if you actually put this in your URL bar, and um, then in theory it should block you. We have a site. We have a question. Some sites check for ad blockers. Could we bypass that with Pi-hole? That's known as anti ad blocking. There's a anti ad blocker that websites put up, and then there's an anti ad blockers. Um, with Pi-hole, you cannot do that because that's all what Pi-hole is doing is dropping down the DNS requests or replying with faulty DNS replies, because it's known as it's a DNS sinkhole. For the bypass, there's some anti ad blockers out there, but if you want to visit the website but you don't have that anti ad blocker, you should disable the Pi-hole for like how much time you ever want to be on it. For example, if you look here, there is the disable button for 10 seconds. So it's offline. You clicked it. That's the status right there. Let's wait 10 seconds. Oh, 5, 4, 3, 2, 1. Okay, it's active now. Yeah. Does that answer you guys' questions? Awesome. Okay. I'm going to stop the recording.